Hi, I'm the History Guy. I love history, and if you love history too, this is the channel for you. Large public works, from ancient pyramids to modern superhighways, have transformed the world. And while these projects are amazing in their own right, they often have unintended consequences that go far beyond the original scope of the project. And that is particularly true of one massive public works project that occurred in the middle of the 1950s. Between February of 1954 and July of 1957, the United States and Canadian governments cooperated on one of the largest and most ambitious construction projects in the history of the world. And in doing so, they transformed Canada. They changed its culture, its economy, its governance, its very geography. It is history that deserves to be remembered. The realities of the Second World War first brought the US and Canada to the realization that we had much to gain by mutual military cooperation. The early risk that England may fall to Nazi Germany suggested that Canada, with its vast natural resources and a relatively small population, might be the next target. Officials in both the United States and Canada recognized the value of joint cooperation in defense of the continent. In August of 1940, Canadian Prime Minister Mackenzie King and U.S. President Franklin Roosevelt signed the Ogdensburg Agreement, which created the Permanent Joint Board on Defense. The board includes both Canadian and American military and civilian representatives, with the task of providing policy-level consultation on bilateral defense matters. The existence of the joint board positioned the countries for further cooperation during the tense times of the Cold War, as both nations became concerned about continental defense, or the protection of North America from the threat of attack by long-range bombers. The obvious idea was to build a line of radar installations that could detect incoming bombers early, giving time to direct fighter aircraft to attack the bomber formations. But both nations were also facing a public demand to reduce defense spending and increasing demands to meet their NATO commitments in Europe. And radar technology at the time had its limitations. It was expensive. It was relatively short-ranged. It required large support teams. And if you put your radar installations farther out on the frontier where they could detect Soviet bombers earlier, that magnified the difficulty of building and maintaining such installations. Plans for a joint early warning system started as early as 1946, but it took the first Soviet test of a nuclear bomb, called First Lightning, August 29th of 1949, to finally compel the U.S. Congress to appropriate funds. The first continental radar defense line was called the Pine Tree Line. The joint project was constructed around the 50th parallel, under the philosophy that a Soviet attack would likely center on major population and industrial centers. But even as it became operational in 1954, it was, in many ways, outdated. The line used classic pulsed-mode radar, which was relatively short-ranged, imprecise, and often unable to detect objects flying close to the ground. Additionally, the location of the stations close to the population centers they were protecting provided only limited warning time. While parts of the Pine Tree Line remained in service into the 1990s, it was clear from the beginning that the Pine Tree Line would provide insufficient protection from bomber attack. In 1956, construction began on a new line of radar stations across the 55th parallel. This line used newer forward scattered bistatic radar technology with greater range and automation. The so-called Mid-Canada Line was seen more as a supplement for the Pine Tree Line than a replacement, and unlike the Pine Tree Line, was wholly funded by Canada and staffed by Royal Canadian Air Force personnel. But despite the new technology, the Mid-Canada Line also had technological limitations. While the bistatic radar technology meant that the radar could detect to higher altitudes and longer ranges, it was not able to determine exact locations, and as such was more of a tripwire than a useful tool for vectoring fighter interceptors. Just as problematic, the radar signal could be overwhelmed by flocks of birds during migration season. Like the Pine Tree Line, the Mid-Canada Line was largely outdated before it was operational, and another, more capable line was being planned, even as the Mid-Canada Line was being constructed. The final line was, by far, the most capable, utilizing newer technologies and placed much farther towards the North Pole, as the pole was the shortest route that Soviet bombers would take if attacking into North America. While improved radar technology and automation made it more practical to staff a line so far north, the Distant Early Warning Line, or DEW line, was nonetheless an ambitious feat of engineering. It planned to take some of the world's most advanced technologies and place them into some of the world's most remote and inhospitable environments. The DEW line would be placed along the 69th parallel, 200 to 300 kilometers north of the Arctic Circle. The DEW line stations included two types of radar. The long-range detection system had two back-to-back antennas, one with a pencil beam for long-range precision detection, and one with a square beam for general search with a wider beam. Those antennas would be flanked by shorter-ranged bistatic gap-filler radars, which would detect any aircraft trying to sneak between the long-range radar. That system was similar to the one that was used on the Mid-Canada line, but used the Doppler effect, which allowed it to filter out slow-moving objects and avoid the issues with migrating birds blocking the radar. The two systems provided a more comprehensive barrier than the previous two echelons, and location at the edge of the Arctic offered far greater warning of an attack, allowing better time to plan and ready both defensive interceptors and strategic bombers that would allow counterattack. The stations were connected to each other and command and control through a communication network called the White Alice Communication System, or WACS, that required large parabolic antennas. Because of the remoteness and inaccessibility of the locations, the stations needed to be designed for both self-sufficiency and for mutual support. The designs had to include extensive storage facilities, repair and maintenance capabilities, and multiple system redundancies. Merely doing the survey to identify the 63 sites that stretched from Alaska to the Baffin Islands was an epic feat. There was no infrastructure in the north of Canada. Survey teams operated in primitive conditions and extreme weather to try to identify locations that you could access via water for construction and resupply, that had room for airfields, that had ground where you could build an installation, or if not, enough gravel nearby that they could literally build ground to build an installation, and of course, most importantly, that had an unobstructed radar view to the north. The construction process was massive, involving some 25,000 people. 3,000 members of the U.S. Army Transportation Corps managed the sea lift during the brief summers. Materials were airlifted by massive U.S. Air Force ski-equipped Lockheed LC-130s, as well as Douglas C-124 Globemasters and Fairchild C-119 flying boxcars. The rugged conditions for construction and supply created a market for short takeoff and landing bush planes, like the de Havilland Canada DHC-2 Beaver. Whatever could not be moved by plane or boat would be dragged in cat trains of sledges dragged by snowcats and bulldozers. In all, some 460,000 tons of material was moved from the U.S. and southern Canada to the Arctic, in some of the most difficult-to-reach locations and brutal weather conditions on Earth. Subcontractors then used thousands of workers to transform those into bases, building housing, airstrips, aircraft hangars, outdoor and covered antennas, and antenna towers, often in the dark and in sub-zero temperatures. Despite the challenges, the line was constructed quickly, and in 1957, 2 years and 8 months after the decision to build was made, the line was operational. The 63 stations came in different sizes. Some were unmanned and only required maintenance during the brief summers. Others had crews of just 3 people. Larger stations might have as many as 100 personnel. All those people so far up north that in the dead of winter the temperature outside might be as low as minus 60 degrees Fahrenheit. The construction and operation in what was previously an almost completely undeveloped part of the world did offer some economic and scientific benefits. Small bush plane operations that got supply contracts got so much business that they grew to major airlines, with both Canadian Airlines and Eastern Provincial Airlines deriving from such operations. Likewise, Canadian electronic contractors with supply contracts gained substantial business and grew as an industry. The DEW line provided opportunities for research and scientific development. The experience in the construction provided valuable insights into building and maintaining materials and bases in remote locations and extreme environments. And the stations offered an unprecedented opportunity for the study of Arctic weather and oceanographic study. But the DEW line also offered unique challenges in environmental impacts. Building and maintaining the stations required roads that cut through the permafrost, damaging watersheds and wildlife migration routes. As the bases required significant storage due to the difficulty of resupply, they had many tanks, both above and below ground, with which time have leaked millions of gallons of fuel and dangerous chemicals. A Canadian project to remediate the environmental damage from 21 DEW line sites that were decommissioned in the 1960s, conducted between 1996 and 2014, was the largest environmental cleanup in Canadian history and cost $575 million. The scope of the project was staggering, with hundreds of thousands of cubic meters of contaminated soils and debris. Some soil was so contaminated that it had to be removed to facilities in the south. Others were buried in specifically constructed landfills. But one of the most significant effects of the manufacture of the line was on Canadian culture and the native peoples of Canada's north. While there was a concern about the effect on these remote populations from the start, Canada appointed Northern Resource Officers to represent their interest. The impact on culture proved to be beyond management. While it offered a pipeline of government services to populations which previously had been largely ignored, and offered economic, educational, and healthcare opportunities that were barely existent previously, DEW line operations also had an irreparable impact on the hunter-gatherer peoples of Canada's north. As one Canadian university professor noted, "In all of recorded human history, there is no group of people who went from hunting and gathering culture to a modern one in such a short period of time. The resulting upheaval left the Inuit with deep social scars, and the concurrent risks of a new sedentary wage economy, including new health risks and challenges like alcohol-related violence." Like the Pine Tree Line and the Mid-Canada Line, the DO Line, one of the most ambitious construction projects in world history, was largely outdated before it was even completed. The advent of nuclear missiles made these sites that detected only incoming bombers less important. In 1985, the United States and Canada came to an agreement to dismantle the DO Line. Some stations were upgraded with better radar, other stations were simply decommissioned, and the last official DO Line station was decommissioned in 1993. What is left is now called the North Warning System, and unlike the DO Line, those stations that are in Canada are manned exclusively by Canadian personnel, while the United States mans those stations that are in the United States and helps to fund the entire system. The project was extraordinary in its scope. It was a marvel of its time, and it was part of that system that purports to have prevented nuclear Armageddon via mutual deterrence. But like every great project, it had implications far beyond its intent, and it transformed the north of Canada, both physically and culturally. And it might have offered lessons that will be useful in the future as the world faces new challenges. It is history that deserves to be remembered. I'm the History Guy, and I hope you enjoyed this edition of my series of short snippets of forgotten history about 10 minutes long. And if you did enjoy, please go ahead and click that thumbs up button, which is there on your left. If you have any questions or comments, feel free to write those in the comment section. I will be happy to personally respond. And if you'd like more snippets of forgotten history, all you need to do is subscribe.